In this video, we're going to look at interpretations, specifically with regards to trig graphs or trig functions. So over here, we were given two functions. Now that is generally how questions like this will be asked. Either you are given two functions drawn already, or you are asked to draw two functions, or they give you one sketched and then they ask you to sketch another one on the same Cartesian plane. And then afterwards, they ask you questions about these graphs, about their individual properties, but also about the relationship between them, or distances between them, or some sort of inequality type question. And then also some transformations and stuff come into play. So let's firstly look here. We have a red graph and a green graph. I just color coded them because that's what works for my brain. So I would advise, if you are given two graphs on the same Cartesian plane, highlight one of them so that you can see which one is which a little bit more clearly. Already looking at this, just as the equation, but also the sketch, our cos graph was multiplied with 2, meaning our amplitude changed, our graph was stretched. Whereas sin, there was no change in amplitude, it's a normal sin graph, but then it was moved, it was shifted, translated 1 unit down. And then this is just saying we're working in between 0 degrees and 360 degrees, including at those points. That's what the square bracket, the braces, no, not braces, we call this brackets. So firstly, they're asking us for the period of f. F is the green one, okay, which is a cos graph. So do not let them fool you when this interval over here is not a full 360 degrees. Even if this is not 360, the period of the graph in grade 10, if it's sin or cos, will always be 360, which is what it is in this case. Oh, that's a very, very big degree sign. And then tan will always be 180, again, in grade 10. We have some period changes in grade 11, but do not worry about that. We do one thing at a time. So, just again, the period of a graph is how long it takes for said graph, for that graph, to complete a full cycle. So, if we look at f, here it starts. Then it goes down, there's a point of inflection here. Then it goes down, changes direction here at the turning point, goes back up. There's again a little bit of point of inflection. Don't worry about that word too much. And then we right back where we started. And then the graph would go down again because our sin, cos, tan graphs are cyclic, right? They repeat and they repeat and repeat. That's why we restrict them, because we don't have time to draw this whole thing. We're not computers. So 360 is going to be the period. Amplitude of f. So amplitude is most the distance. So between where the middle of the graph is, which is here, from here, or the point of equilibrium, which is a very fancy word for where the graph is balanced, the point at which the graph is, around which the graph is balanced and revolving and whatnot. So that's the x-axis in this case, because the graph is not moved up or down. So it's a distance from here to the highest point or to the lowest point, to those turning points, which is 2. You can also read it from there. So just on that note, that would make this y value over here 2, and then this lowest y value there, -2. Okay. We could have also looked at the amplitude of the sin graph, which is 1, because it has not been stretched. There's no other number in front of sin. And here also, if you wanted to draw the point of equilibrium there in the middle, that distance would be 1 unit, because that's a 1. Okay, so just keeping that in mind, this would make this -1. Okay, that's the point 0, or the y value 0. Then range of g. Now we're working with the red graph, with the sin graph. So range is always an interval. And specifically range is our interval of y values. So we're going to say between which two y values the graph exists. Okay, for example, you can't choose a y value here and it cuts the graph. It doesn't. It doesn't have an x value that matches to make a coordinate. So you go look at what's your biggest value, which is 0. Everything else is below. And your smallest value, which is here at -2. So it's between -2 and 0. Always from small to big. You could also write it in the other way where you say y is an element of interval that starts at -2 and ends at 0, and it includes both of those points. The round brackets would mean does not include, would be the same as not equal to here. So just the greater than sign. In maximum value. So when we're talking about a maximum value in functions or graphs, we are looking at the maximum y value, not x, okay? Maximum y value. So in this case, you go look at f is the green one. What's the biggest value it can have? Okay, it's here on top. It happens here as well as here, and it is 2. Then calculate the length of AB. So A is way up here, and there's B. So there's more than one way you can do it. You can use distance formula from analytical geometry, though that is a little bit overkill, but I mean, you can. You'll get your marks. Or you can, for your y values, you can say basically the big one minus the small one. And that would be the same for horizontal distance, the big one minus the small one. So our length of AB, the biggest value between these two is A, or the biggest y value is at A, which is 2, minus the smallest y value, which is at -1. So this is the same as 2 plus 1, which is 3 units. You could have also, of course, seen, okay, from A to the x-axis, that's 2 units. And from the x-axis to B is 1 unit, so 2 plus 1 is 3. That's another way. Now, we are going to look for or write down the coordinate of D. So D is a point on the green graph on our F, which is 2 cos x. So, and we can also see that it's the turning point over here. So from that, we know, also it's 9 there, that the y value will be -2. Okay, we always say x, then y. Then if we go look here, the important points on our sin and our cos graph is every 90 degrees. So usually this will be indicated, in this case it wasn't, but here would have been 90 degrees, okay? This first turning point slash the first time we cut the point of equilibrium. Then the next will be here, which is 180 at this turning point, which is also where it changes from concavity. Don't worry about that word too much. Then here's our next one, 270. And then our last one would be somewhere here, which is 360. I don't know when I made this on GeoGebra what these intervals were that I had there. Okay, so please ignore those lines. Okay, so from that, this turning point would be at 180 degrees. Next question is asking us about the range. So we know again, just like the previous, we're going to look at the y values, the smallest one and the biggest one. But it's for a new graph, so there's some transformation now here. And the transformation to create h was done to g. And g is the red graph. So what happened to this graph now is it was reflected. That's why we have the minus, and it's reflected about the x-axis. The 2 means it was stretched by a factor of 2, and the +1 means it moved 1 unit up. It's not unit up. So what we're going to do first, there's more than one way you can go about it, but I would advise let's go write down the new equation. You make brackets where you're going to go substitute that graph's equation, and then you go substitute. So this is sin x minus 1. And the reason it's so important that you remember this bracket is because that negative 2 is not only going to affect the sin x term, but also the negative 1 term. So you'll have negative 2 sin x, and then minus 2 times minus 1 is plus 2, and then we have plus 1. So in other words, we have negative 2 sin x plus 3. So that's one portion of what we had to do. The other portion is now actually finding the range of this new equation. So for our y values, we know it's going to be in between two values. And usually if the graph has not moved up or down, if it's just the normal sin graph with a number being multiplied with it, that number and its additive inverse, okay, so if you have 2, additive inverse is negative 2. So basically that number will be, the positive version of it will be our biggest value, and the negative version would be our smallest. So negative 2 and 2, usually. But then the graph also moved up 3 units. So then you just add 3 also, and then we'll get our smallest value is 1, and our biggest value is 5, which does add up. If you look at this distance, it's 4, meaning our amplitude would be 2, which does add up with what we have here. Another way you could have done this, and I'm going to just do it over here on top, is you could have looked at G as it is now. If we look at the minimum and the maximum value G currently has, and you apply this transformation to it. So negative 2 times what the smallest value was, and negative 2 times what the biggest value was, and then you plus the 1 each time. So our smallest value for G we had earlier, and it is negative 2. And our biggest value was 0. So if you go find these answers, this would be 5, and this would be 1. Okay, now of course you can see that the one that I say is min is now the biggest, and where I said max is now the smallest. And that is because that negative flipped the graph. So the smallest value became the biggest, and the biggest value became the smallest. Okay, but then you can also see, okay, there's our two values. So we're going to work between 1 and 5. So that's another way. Or you could have gone and worked with your calculator, and you just substitute some of this part into your calculator. You make your interval 90, and then you go look at what's the biggest y value it gives to you in that table method, and what's the smallest one, and you would get the same answer. But you still need to know how to do this method, because it's not necessarily that they just asked for the range, or that they asked the range at all. They could have just asked you, okay, this is what happened to h, write down the equation of h. So then you would need to do this. This is another transformation question. It's the last one we're going to do of this, and then we're going to look at some intervals. So for this last transformation question, now we're working with equation J. So let's see what they say is happening to a graph to create J. So it's happening to F, and it's being reflected about the x-axis. So we already know straight away we're going to have negative f of x now. And then it is shifted 1 unit down. 1 unit down is a minus 1, but it's only happening to the y value, to the constant term. Y values, sorry, so that's really the equation. Remember, f of x is the same as y. And then you can do the same as we did earlier. We go substitute, but this time we're going to substitute f of x. So then we'll get negative 2 cos x minus 1, and that's our new equation. Of course, you just need that j of x part. It doesn't have to be written again, because remember, equations, we can read all the way from here. Everything here is equal to the bottom. Now for the part that people tend to find the most tricky. Not because it has to be, but it's not the easiest part of maths. But with practice, you should be able to get the hang of this. So this first one is asking us, where is g of x equal to 0? So we need to firstly know that g of x, h of x, j of x, whatever of x means y. So they're asking you, where are the y values equal to 0? In other words, where's the x-intercepts? And this is now for our red graph. So we go look here. Okay, here's the first place. And that happens to be the only place where our graph is cutting the x-axis. So it's at which x values? So it's at x equal to 90 degrees. Then our next graph or next question asks us, where is f of x less than or equal to 0? So they're asking us, where's the y values of this graph less than is negative. So in other words, where are we? Below the x-axis. So if you want to, you can even go and you say there, everywhere here, okay, we have positive y values. Then it changes there. Then there, I don't know why I put a 0. Then they're negative. And they're negative for quite a while, all the way here, negative, negative. And then they change again to positive. So it is negative from this point to this point in between, but they're also asking 0. So we include 90 where it's 0 and 270 where it's 0. So it's all the x values that is in between 90 degrees and 270. They're also below the x-axis, with the x-axis being there. In the next question, while we're at it, if we want to, we can just add here, everywhere we have negative values except at that point where we have equal to 0. So now we are being asked, where are the y values of g bigger, so greater than, those of x, those of f. So where is g essentially above? So if we look here, everywhere here we have the f having bigger y values because it's above. There it changes. So we know where they intercept, that's going to be our critical parts. Then everywhere here, we have the red being on top. So in other words, the red graph has bigger y values than the green one, which is f. So it's for all the x values in between 90, the one point of interception, and the other point of interception they gave us there, because we can only next year do these tricky parts like that. But we do not put equal because there was no equal sign there. And then again after this, the f graph has bigger y values. And then here's everyone's favorite one. So they're asking, where's the product of the y values? Negative or 0? So in other words, where's f positive or 0 and g negative, or f negative and g positive? So we already know g is always negative, except there where it's 0, but we want that part also. So this portion is not possible. So we need to see where is the y values of g negative, but f has positive. So here, in this whole interval, then there it's 0. Okay, 0 times 0. So then they're both negative. Okay, we don't want that, we don't want that. Yeah, at this point, it changes again. We have negative and we have positive. So it's those two intervals. So it's when x is anywhere on this side of that 90, or x is anywhere on this side of that 270. And then obviously numbers towards this side is bigger, so we can just create like that. So it's where x is smaller than 90, or 270 is smaller than x. So it's at those 2 points. We can say or, if we want to, or comma, semicolon, slash. Do not write the word and. When we get to probability, we'll see why that is a no-no. And that is that for this video. I know that some of this can be a bit overwhelming at times, but with practice, you can do this.